Hello and welcome to Engineering Simple. This video will provide an example of how to refer the impedance from one side of the transformer to the other side, and also how to apply per unit. So let's go through an example to calculate the per unit. And by the way, if you would like to know more details on per unit, I would recommend watching other videos that I created in this regard. So here's an example: three-phase auto transformer, 12 MVA. The high side is 240 kV and the secondary side is 120 kV. The impedance is 4.6% on the transformer's ratings. So the question is, what is the transformer impedance on a 50 MVA and 230 kV base? So here's an auto transformer. It's a three-phase. So here's one winding. So that's the primary, and the secondary is just from H1 to the neutral, or HO, XO in this case, that's the primary, and from X1 to HO, XO, that's the secondary. So from a previous video, we have this formula on how to calculate the per unit impedance on a new base, provided that it's given in an old base. And I would recommend watching previous videos on per unit, because they go extensively on how to calculate the per unit on a new base. So I'm just gonna replace the terms with values. So the per unit impedance on the new base is equal to 4.6%, which is given here, divided by the line to neutral voltage on the old base, which is 240 kV divided by square root of 3, divided by 230 kV divided by square root of 3, which is the new base, quantity squared times new base MVA, which is 50, divided by old base MVA, 12 MVA. So it comes to 20.87%. Now let's do an example on how to refer impedance to the primary side. So we have a single phase transformer, 7,200 volts primary and 240 volts secondary. And here's the impedance for the primary. It's the resistance is 0.3 ohms and the reactance is 52 ohms. Here's the secondary resistance, 0.0005 ohms, and the reactance is 0.058 ohms. So the question is, what is the equivalent impedance on the primary side? So here is a two-winding transformer. So the primary, here is resistance, reactance. Here is secondary, resistance and reactance. So we would like to reflect the secondary impedance to the primary impedance. So from a previous video, I derived this equation here. So I'm going to use a portion of it. So basically the primary impedance divided by the secondary impedance equal to the square of primary voltage divided by secondary voltage. So what I did, basically I just squared this quantity here to get rid of the square root of 2. So then if I rearrange this equation, the primary impedance is equal to the secondary impedance times the ratio of the primary voltage divided by the ratio of the secondary voltage, quantity squared. So now just the secondary impedance reflected to the primary. So I just take the secondary impedance, which is here, times the ratio of the voltages, which is equal to 0.45 plus J times 52.2 ohms. So that's in a rectangular form. Then now, if I want the primary impedance equivalent, so I'll just take the primary impedance plus the secondary reflected impedance and sum them up. And I get 0.75 plus J times 104.5 ohms. Then I can convert that to polar form and then to exponential form. I made a video that talks extensively on these three forms, so I would recommend watching them if you want to know how I came up with these numbers. So as you can see from this sketch here, I had primary impedance and secondary impedance. Now I reflected and I just added a prime, so R2 prime plus JX2 prime. So prime just means it's the secondary impedance reflected to the primary. Now let's see an example on how to refer the impedance to the secondary side this time. So I have the same example. So what is the equivalent impedance on the secondary side? So I'm going to use the same ratio you saw in the previous slide, except I'm going to rearrange it to get the quantity for the secondary impedance, which is here. So secondary impedance is equal to the primary impedance times the ratio of the secondary voltage divided by the primary voltage squared. So now I will take the primary impedance alone and reflect it to the secondary side. So that's what I'm doing here. Here's the primary impedance times the ratio squared. So I get this number here. Now, if I want the secondary or the equivalent of the secondary impedance, I'll take the secondary impedance plus the reflected impedance of the primary and sum them up. Then I can convert it to polar form or exponential form. So you can see the primary impedance is reflected here, and I added a prime to indicate that it's the primary impedance reflected to the secondary side. Now, how to convert impedance from ohms to per unit. So we have the same example. So the question is, what is the transformer per unit impedance? So I already did these calculations, so I'm just going to show them. So all these calculations here are per unit, in ohms. Now, we know the base impedance is the square of the line to neutral voltage on the base divided by the apparent power of the base. So if I use my high side or primary side, the line to neutral voltage is 7,200 volts squared divided by 50 kVA or 50,000 VA. So the base impedance is 1,036.8 ohms. That's on the primary side. On the secondary side, it's 240 volts squared divided by 50,000 VA. So it's 1.152 ohms. Because you have primary and secondary side. They have different voltages, but the same kVA. That means they're going to have different base impedances. So now the per unit impedance on the secondary base, so it's just the secondary impedance divided by the base of the secondary impedance. So if I just plug numbers, so I'll get this value here. Now if I do the calculation on the primary side, so the actual impedance, which is just for the primary side, is 0.3 ohms plus 52 ohms. So that's what I have here, divided by the base impedance for the primary side, which is calculated here. So I get, there are some errors in rounding up and that and so on. Otherwise, these two numbers, they should match exactly, and you can see they are almost the same, because that's the beauty about using per unit impedance, because then you don't, so if you look here, the primary impedance is in ohms, it's way different than the secondary impedance. But in per unit, it's one value. It doesn't matter which primary or high side, and you can see that here. So that's one way why per unit is used in power system analysis rather than actual units, ohms, for instance. So then when you do per unit, it's just a true impedance. So you can see it's per unit. We don't care if it's high side, low side, primary side, secondary side. However, if you want to get the actual value like in ohms, then you have to use the right base values. Thank you for watching this video, and if you would like to know more about transformers or other topics, engineering topics, I would recommend going to Engineering Simple. Thank you and have a good day.